Hello, welcome everyone to the How to Go Solar Plus Storage Workshop. My name is Abigail Jager. I'm a program manager with Solar Oregon. And thank you so much for coming today. So, on the agenda for today, we'll be looking at many aspects of how solar and battery storage works. We'll start by taking a look at how solar works. We'll see the components in a typical solar system, learn about a process called net metering that allows you to get credit for the energy you export to the electrical grid, and see how solar saves you money on your utility bills. Next, we'll take a look at how a solar contractor assesses your home and how you can know if your home is the good fit for solar. We will then talk about dive we will then dive into the exciting and popular topic of energy storage and see how a battery can allow you to have energy resilience and allow you to save even more money. We will then talk about incentives and how you can save money on your solar installation. Then we'll wrap up by talking about how you can get started. The goal of the presentation today is to get your questions answered. So after the main presentation, we will be having an extended Q&A. Any and all questions about solar and battery storage or even related technologies are welcome, and I will do my best to answer them. During the Q&A, please use the Q&A function at the bottom of your screen. It's highlighted in an orange box here. You'll be able to put your questions in at any point in time. You don't need to wait until the end of the presentation to put them in. So if a question comes up in the middle of the presentation, feel free to use it. While I go through the last few housekeeping things, I'm also going to launch some polls. These polls are completely optional, but they just let us know a little bit about who's in the Zoom room with us today and is really helpful when we are applying for grants or under other funding. If you wouldn't mind going ahead and fill that out, I'd be extremely grateful. Thank you so much for filling that out. I'm going to go ahead and launch the next poll. And also share. So as I said, I'm a program manager with Solar Oregon. Solar Oregon is a 501(c)(3) nonprofit that has worked to encourage solar and storage adoption throughout Oregon since 1979. We do this by providing reliable and impartial consumer education like this workshop, working to build the clean energy community, informing outreach, and some policy advocacy. We also facilitate solar tours, zero energy showcases, expert panel discussions on a range of topics related to solar, solarized campaigns, and short-term and Solaris campaigns, which can help you go solar. You're able to find more information about other upcoming events we have on our Eventbrite page and via our newsletter. I'm going to go ahead and put some links in the chat right now. These are just some general informative links that I'll be referencing throughout the presentation. And thank you so much for filling out that poll. I have one last one I'm going to launch. This workshop today is made possible by Energy Trust of Oregon. Energy Trust is an independent nonprofit established in 2002 that provides resources to help enable customers of the investor-owned utilities in our state to use energy efficiently and gain access to renewable energy. They offer key incentives for solar installation and battery storage and coordinate a network of solar trade allies who are able to offer these incentives. We will talk more about the solar trade allies later in the presentation. I want to thank Energy Trust for their support in making this workshop possible. If you would like to learn more about Energy Trust, you can check out the link in the chat. It would go to energytrust.org. And thank you everyone for filling out that last poll. And with that, we're going to move on to the main presentation, starting with how solar works. So this is a diagram of a typical home solar system. You can see in the top left the photovoltaic or PV panel. This is what it would be mounted on the ground or on the roof of your home. And when sunlight hits the panel, it generates a volt of electricity. However, the volt of electricity it generates is called DC electricity or direct current electricity. This is different than electricity used by your home, which is AC electricity. So from the solar panel, it has to flow into the inverter or microinverter, which is a special device that you'd get installed along with your solar panels. I'll be explaining more in a minute, that converts the DC electricity generated by the panel to usable AC electricity for your home. If at from those inverters, from the inverter, the electricity then flows into your home electric panel where you can use it to charge your devices, run your computer, charge an electric vehicle, and power all your lights and just anything you use electricity for. If at any given point in time you're generating more power than your home is using, so if you're at the office all day and your solar panels are generating sun, but there's no one in your house, that would be one example of that. The excess electricity you are generating will flow out to the utility grid to be used by your friends and neighbors. And then similarly, if at any point in time, such as at night, when your solar panels will be generating very little, if any, electricity because the sun's not out, the utility meter that you get installed with your solar panels is bi-directional. So you're able to both send electricity out to the grid through that utility meter, but also pull it back to your home. So you can use power and electricity at night. This is called a grid tied system as you're still connected to the main utility grid. Overall, you can see that the main components of a solar system are very simple, and it's one of the reasons solar's a great option for many people is that it's highly modular and therefore highly customizable to your specific home. So now let's take a closer look at inverters. So pictured here on the left, we have a typical inverter, also called a string inverter. The inverter would be placed either next to your electric box or on the outside of your home, and it takes in all the electricity from all your solar panels at once. So if you have 10 solar panels, you would still have just one inverter. If space is not available near the breaker box, it can be installed outside. However, that can lead to some extra costs. With a typical string inverter, you might also need to install a second device called a DC optimizer that just makes it so you are losing as little electricity as possible throughout that process. The other great option are microinverters, which are pictured on the right, highlighted within this orange box. Microinverters are great options that are installed frequently throughout Oregon, and however, they only take in electricity from 1 to 2 solar panels at once. So if you have a solar system of 10 solar panels, you could have up to 10 microinverters. They would be mounted on the backside of your solar panels as pictured here. Both inverters and microinverters are great options that are installed frequently. Your contractor may suggest one or the other based on the specific needs of your system, and it's a great idea to ask them why they picked one during the design process. In order to be ready for solar, your main breaker needs to be rated for at least 200 amps. In most cases, larger homes will require a larger breaker for solar, while some smaller homes may be able to manage with less amperage. Common signs that you need to replace your electric panel before installing solar panels include your main breaker being rated for less than 200 amps. You plan to install solar battery storage and or an EV charger either now or in the future. You plan to install more electric appliances like a heat pump or heat pump water heater that just also require more amperage. You plan to install a pool or hot tub now or in the future, and you're already experiencing issues with your current electric panel like tipped breakers or flickering lights. Electric panel upgrades are very common. However, they can lead to some extra costs as hopefully your electric panel would be situated already. Solar panels can be mounted either on your roof or as a ground mount. Roof-mounted systems account for the vast majority of solar installed on homes and businesses, especially in dense urban areas where ground space is not available. Ground-mounted solar systems can be a great option for families with more space. However, because they still need to be wired into your home's electrical panel, ground mounts installed far from the home can increase the total cost of the system. This cost is partially due to the high price of copper and wiring, as well as expenses related to burying the wire underground. However, if you have a space, ground mount can be a really great option. So now that I've done some of the basics of solar, I'm going to explain the process called net metering, which is how solar helps saves you money. So I'm going to explain net metering by first walking through two examples. First, looking at a typical sunny summer month and then a typical cloudy winter month. So the graph on the left shows us what's happening in a summer month. The orange bar shows how much electricity you've produced with your solar panels, and the blue bar shows how much you've used with all your lights, appliances, and outlets. Because you produced more than you've consumed, this is a month you're exporting electricity. The green arrow shows the difference, which is your net metering credits earned. Net metering credits roll over month to month, so you're able to build up those credits all summer long. And then once we get to winter, we were thinking it looks pretty sunny today, but we're thinking about a typical cloudy winter day where it's going to be very overcast. Your The graph on the right shows us what that would look like when you're using a similar amount of electricity, illustrated by that blue bar on the left, but producing less with solar. Your solar panels will still produce some amount of power even when it's cloudy and overcast. However, it's typically much less than a sunny summer month. So the red arrow shows the amount of electricity you'll need to purchase from the grid in order to make up that difference. With net metering, the credits you earn during the sunny summer months offset the electricity you purchase in the cloudy winter months. As I said, net metering credits roll over from month to month. That's what allows the system to work. However, it's very important to remember that they do not roll over from year to year. The net metering year begins and ends around April 1st, and this allows you to build up the credits during the summer month and use them all winter. However, any excess credits you have at the end of March, depending on your billing cycle, when the net metering year ends, are donated to the grid for low income customers. And unfortunately, your utility will not give you a check for those donated credits. So now let's look at what this would actually look like when it shows up on your bill. So on the bill, we can see here the calculated kilowatt hours, which is the unit that your electricity is measured in at the beginning of the month and at the end of the month. And we can see that this customer generated or had negative 327 kilowatt hours. That means this month they exported more power to the grid than they were using, and they got 327 kilowatt hours of year-to-date banked excess generation or net metering credits, and therefore their billable kilowatt hours are zero. Oop, apologies. Did not mean to switch to the next slide yet. Because So their billable kilowatt hours are zero because they were a net exporter. However, it's important to note that while their billable kilowatt hours are zero, their bill for this month would not be $0. There is a certain amount of base charge that comes with being connected to the electric grid, as well as some taxes and fees depending on where you live. This usually works out between $12 and $18 per month, but it does change depending on where in the state you are. And when you think about it in comparison to the average Oregon utility bill, it is about $100. So this is already a really great deal. Now, as I said, solar is highly modular and solar systems vary widely in size. System size is measured in a unit called kilowatts, and the average residential size in Oregon is 8 kilowatts. What determines your system size? By far the biggest constraint is how much electricity you consume. This is because, as I mentioned, net metering credits do not roll over from year to year. That means that to get the most value out of your system, your contractor should design it to meet but not exceed your estimated annual consumption. Your contractor will ask for your past electric bills in order to try and determine your future needs, but it's also important that you let them know about any life changes that might impact your electricity usage. This can include switching between gas and electric water heaters, purchasing an electric vehicle that you intend to charge at home, or having a child move out or someone else move into your home. Other factors that can limit your system size are available roof space, your budget, or limitations placed by an HOA, condo association, or historic district, though it is important to note that it is illegal in Oregon for HOAs to tell you that you can't go solar. However, they can impose restrictions on how you go solar, such as preventing you from installation on the street-facing side of the home. If you are having issues with an HOA and going solar, please reach out to us at info@SolarOregon, and we're happy to provide you more information about those laws and help in any way we can. So now that I've gone through kind of the basics of solar, how can you know if your home is right for solar? Regardless of your location in the state, the orientation of your roof has a big impact on your solar access. This diagram shows a home and its orientation with respect to the cardinal directions. The arcs over the home show the path of the sun in the summer and the winter. Regardless of the season, we can see that the sun will always be in the southern sky. This means that south-facing roofs are ideal for solar. However, both west and east-facing roofs can work great. In cloudier parts of the state, roofs facing due east can be slightly less effective, and this is because clouds tend to persist through the early morning, blocking some of that sunlight. The only roof planes that consistently don't get installed on are north, northwest, and northeast facing. Now, even if you have a perfectly south-facing roof from objects like trees and building, shade from objects like trees and building can prevent you from receiving enough solar in order to make it a viable option for your home. However, it can be very hard to self-assess whether shading from your roof receives is actually at the degree where it impacts your ability to go solar. Your solar contractor will be able to assess this for you with precision, either using special measurement devices or satellite-based software. If your home is overly shaded from trees or other buildings, a great option to look into is community solar, as that is solar that is located not on your roof, but located elsewhere and still allows you to get some cost savings. And there's a link for more information about that in the chat. Now, one of the biggest factors that can affect whether you're able to go solar is your roof, both the condition of your roof and the supports under it, as well as the complexity of your roof structure. Your roof will need to be replaced when it reaches the end of its lifetime. And when you do that, you'll need to pay, if you already have solar, you'll need to pay a solar contractor to install and reinstall your system. This can cost over 10 grand, and it's very important to plan ahead. And it's also very common if you are having to remove and reinstall solar panels during a process like this for solar panels to get damaged or just not working well once they are reinstalled. For this reason, we strongly recommend that you have 10 plus years of roof life left when you install solar. Different roof types have different lifetimes, with metal roofs typically having a much longer lifespan than asphalt shingles. However, virtually all roof types can work well with solar. If you are expecting to need to re-roof in the next few years, you should wait until that time to install solar so that the roof life matches the life of the solar panels. The complexity of your roof can also impact your ability to go solar. Solar systems can be split into several sections and span multiple roof planes. However, the ideal roof will allow for a single continuous installation on one roof plane, and this just saves on complexity and therefore cost. And as I said, it not only matters what's on top of your roof, but also what's under it. Solar adds extra weight to your roof, and so your roof needs to be adequately supported for that weight. Newer homes tend to have trusses. These extra vertical and horizontal support beams meet even the strictest requirements for solar. Older homes tend to lack these extra support beams and might just have rafters extending from the eave to the crest of the roof. In this case, your home may still meet even stringent requirements, but based on the geometry of your attic, your contractor may need to hire an engineer to perform calculations for the permitting office in order to prove that they are sufficient. These extra costs occur particularly for older homes built pre-1950s in Portland, especially with urban craftsman architecture. In rare cases, your home may not be able to meet local code requirements, even with reinforcements, and you can also be prevented from going solar if your attic is inaccessible or there's not enough room for your contractor to perform the necessary reinforcements. So there's lots of things to consider, both on and above your roof. So now that I've done some of the basics of solar, we're going to dive into the exciting topic of battery storage. So it's important to know that your solar system by itself does not allow you to use your solar electricity during a power outage. In order to do this, you'll need to add a battery. The ability to use power when the grid is down is called energy resilience. Solar and battery storage are complementary technologies. Solar makes the battery more effective by recharging it, and your battery allows you to access your solar independently from the grid. When you're thinking about getting energy resilience via battery, it's important to think about what type of power outage you're planning for, as power outages vary in their causes, their frequency, and their duration. Frequent short outages are usually caused by either storms or squirrels, and in some areas, slightly longer outages in the summer months can be called by red flag weather conditions where there is a high fire danger. In the Pacific Northwest, we also face a unique risk of a large earthquake, the Cascadia seismic hazard. When this event occurs, it's thought that power may be lost in the Willamette Valley for up to 6 weeks. On the coast or other rural parts of the state, power may not be restored for several months. It's important to know what type of outage you're expecting so that your contractor can design a system that will meet your needs, or at least be honest about the limitations of the system they are designing. If you are wanting to prepare for an extended outage, you will likely need multiple batteries to store more energy, which will increase the upfront cost. When choosing a battery, there are many quality options. But however, because manufacturers, certifications, contractors often specialize in a specific brand. To compare battery technologies, you may need to get quotes from multiple contractors, which we recommend you do anyway. It's important to know that you cannot mix battery brands. So if you already have a Tesla Powerwall, you would not be able to add on an Enphase battery to that same system. However, your solar panels and other technologies can be a different brand than your batteries. Battery capacities are measured in kilowatt hours or kWh. Most batteries range from 10 to 14 kilowatt hours. Smaller units exist around 3 to 4 kilowatt hours, while larger ones go up to 20. In Oregon, the average battery size is 13.5 kilowatt hours. For standard household electrical loads, many batteries will work well. If you're intending to use the battery to back up a load that requires a lot of instantaneous power, like a motor, your contractor will need to factor that into the system design. If you're interested in installing a battery, when you install it can affect both the system design and price, but generally there are two options: installing solar and batteries at the same time or adding a battery to an existing solar system. And this just impacts the price because it is about how the price changes over time, available incentives, and having to repull permits and get your contractor out a second time. There are also occasionally incentives that are only available if you're installing solar and batteries at the same time, though we are working to change that in the state. Late additions of a battery may also lead to inefficiencies like space constraints, longer conduit runs, and extra labor. Batteries do need a dedicated space, ideally near the electrical panel, often in the garage if space is tight. They can go on an exterior wall, but there can be aesthetic concerns with that. And per the National Electric Code, batteries cannot be installed in crawl spaces, cupboards, or other confined areas. Now, it's important to set your expectations properly about what a battery can do and what it cannot do. Even if you don't use much electricity, a single battery will almost never back up your entire home for a meaningful period of time. However, you can do what is called a partial home backup. In this scenario, certain circuits in your home will receive power from the battery, but the rest of your home will lose power during an outage. If you're able and willing to front the extra cost, multiple batteries can allow you to achieve a whole home backup. This process, though, can be prohibitively expensive for most consumers, but is a simpler and more efficient process overall. When you get a home backup, there are two ways that you can do that. You can first do it via the creation of an essential loads panel. This is how you divide your home into different sections based on what it will receive power, based on what breaker it is on. When you've selected which circuits you'd like to receive battery power, your contractor will remove those breakers and place them in a newly installed smaller essential loads panel. This second panel will be wired to the battery, and in the event of an outage, only that second panel will receive power. There are also some newer technologies, such as smart electric panels, such as the span electric panel, that can provide more customization and flexibility with the ability to move circuits from between three categories of must-haves, nice-to-have, and not mandatory circuits based on the needs and how your needs change. If you have an older home, you also might need to upgrade your electric panel before you go solar, so it's important to think about what type of upgrades you want and if you would like to plan for the addition of a battery as well, either now or in the future. The battery system sizing process will entail a detailed conversation with your contractor, balancing your desired functionality with your budget. A great way to think of this process is the trade-off between two questions: what needs power and for how long? Items most frequently chosen to back up include a refrigerator to keep food from spoiling, lights in common areas, and a couple of outlets to be able to charge a laptop or cell phone. So now that we've talked through batteries and solar, let's look at some prices and also look at available incentives that can help save you money. Energy Trust of Oregon offers a standard solar incentive that is currently $2,500 for solar for both Portland General Electric and Pacific Power customers, and $400 per kilowatt hour up to $5,000 for installed storage, and $320 per kilowatt hour up to $4,000 for Pacific Power for storage. You can receive this incentive whether you install solar and storage at the same time or separately. And in order to receive this incentive, you must have your system installed by an Energy Trust Trade Ally contractor. That ensures that your solar system will meet Energy Trust standards. The Energy Trust Trade Ally Program, I will be talking about more in a moment, but it is a program run by Energy Trust that vets contractors and allows them to offer you this incentive. The only thing you as a customer have to do to receive it is work with the Trade Ally contractor. They will fill out all the necessary forms and ensure they are meeting Energy Trust standards in order for you to receive the discount, and you will just see the discount applied on your bill. If your utility is not PGE or Pacific Power, you will unfortunately not qualify for Energy Trust of Oregon incentives, but your utility provider might have other incentives available, and you should be sure to check them out. And it's also important to note that the availability of this incentive varies and are subject to funding and availability and will change. So this is what they are currently, and they could change at any time. In addition to the standard incentive, Energy Trust also offers an income qualified incentive. This is called Solar Within Reach, and it functions very similarly, where it's a dollar per watt incentive. It allows PGE and Pacific Power customers to reduce their installation costs. In order to qualify for this incentive, you must use a Trade Ally contractor. However, your income must also be within the limits listed currently on the screen. If you'd like to find out more about that, there's a link in the chat, or you can scan the QR code currently on your screen. Because solar and battery storage entail large upfront costs, many homeowners utilize financing. Some homeowners obtain a loan through a bank for which they have an existing relationship, but some banks do not provide loan products specifically tailored to solar. Your contractor may partner with a credit union or third-party broker that offers a package that is geared towards solar. However, you should also do your own research and see in order to ensure that you are making the best financial decision. And as with any major financial decision, make sure you carefully assess your financing options. If you'd like to learn more about financing options, you can also check out our presentation on comparing solar quotes. Energy Trust of Oregon also recently launched the Smart E-Loans program in partnership with Solar Trade Allies and Inclusive Property Capital, a 501c3 clean energy financing platform. ETO Smart E-Loans can be used to install solar plus battery storage paired with a previously installed solar system, an electric vehicle with a solar and/or storage system, and can be also used for enabling upgrades or repairs in order to allow you to go solar, and that can be up to 25% of the loan amount. Some of the benefits of the Smart E-Loans are transparency. There are no fee or prepayment penalties. It is an unsecured loan, so there's no need for collateral. It accepts low FICO credit scores, as low as 580 is accepted. They have flexible terms of 5, 7, 10, 12, and up to 20 years, and rates as low as 6.99% with a very easy application process. In order to access this loan program, you do need to be within PGE or Pacific Power territory. And so be sure to check out your other local banks and credit unions if you're unable to access this. And there's a link to that in the chat. So in just a moment, I'm going to show you some example budgets for solar and storage, but I want to recap that these budgets are just examples, and the quote you get for your solar system might look very different, as the cost of solar and storage can depend on the size of the system, whether or not you need to do any re-roofing, if you have to get structural analysis or structural reinforcement done, the cost of batteries. And the cost of battery storage can depend on if you're installing it at the same time as a solar system versus separately, how far away you're installing it from an electric panel, if you are creating an essential loads panel, and how many batteries you are installing. Additionally, the availability of incentives can impact the price. So please keep this in mind as we look at the example budget. So here we can see an example budget for an 8 kilowatt solar system and a paired 8 kilowatt solar system with accompanying 3.5 kilowatt hour storage system. So the cost for just a straight solar system is $32,000. You can then get the Energy Trust incentive at $2,500, making the total out-of-pocket cost to you $29,500. And if you're getting solar plus storage, the average price would be about $52,000. And you can then claim those Energy Trust incentives, taking the total out-of-pocket cost to you to $44,500. There are other incentives, such as income qualified ones, that can help you save money. And again, there's typically an additional cost if you're not installing solar and storage at the same time. So now, with all this information, how can you get started? Besides offering incentives for solar, Energy Trust of Oregon runs the Trade Ally program that I've already been talking about. This is a certification program for contractors to help ensure a high quality of workmanship. Energy Trust Trade Ally contractors are rigorously vetted, highly rated, and are the only contractors who can offer you the Energy Trust of Oregon solar and storage incentives I've already gone over. We highly recommend working with a Trade Ally contractor and getting at least 3 quotes to compare. Luckily, it's very easy to get those 3 quotes. When you're ready to get quotes from contractor, you can use the Energy Trust website to request a free custom analysis and bid. This online form takes only 3 to 5 minutes to complete and is a great way to make sure you're getting connected with Trade Ally contractors and will connect you with up to 3 contractors that work in your area. You can scan the QR code on the screen in order to access that solar bid tool, or the link is also in the chat. Once you've selected your contractor or received quotes and signed your contract, here's what you can expect regarding the installation process. Your contractor will handle all permitting, applying for the Energy Trust and incentives on your behalf, and designing your system. It's important to remember that they will need your signature on some of these documents, so the more organized you are, the smoother the process will be. Although system design can be quick, some jurisdictions have been experiencing permitting delays, and some counties have longer permitting times than others. For example, Multnomah County can experience large delays frequency. However, once it's time to break ground, installation is very quick. Most residential systems are installed within 1 or 4 days, making it a relatively painless process. Installations for solar is usually pretty quick and it can take more time if you have a complex system design or if you're adding batteries. After the system is installed, your contractor will manage your permit inspections, coordinate the installation of your new bidirectional meter, and schedule your interconnection with the utility. This can take 2 to 3 weeks, and after you've been interconnected, your system will be producing clean, renewable power from the sunlight falling on your property, and you can be excited that all your power is coming from the sun. So now with all that, I'm going to start going through the Q&A. I know there's already some questions in the poll in the chat, so I will start there. So the first question I'm seeing is what percent of homes need panel upgrades and how often do they opt out? So I'm not sure what percent of homes need panel upgrades. It really depends on the age of your home. I've heard of homes with old school wire and knob electric panels that are wanting to go solar and they very much need those upgrades. It really depends on the amperage, and that is a great conversation to have with your solar contractor to see if it is still safe for you to add solar panels to a current breaker or whether or not you need upgrades. The next question I'm seeing is if a home is producing more electricity than they need, why will PGE not purchase the excess energy my solar panels generate? Um, so this really comes down to what their current system is. There have been other systems in the past where PGE will more or less purchase the energy from you, but unfortunately that makes solar very difficult for the electric utility. And so instead, the system currently that exists in the state is where you get a credit that will last for the rest of the net metering year, which, as I said, begins and ends on the end of March. If you would like to advocate for a different system, reaching out to the Public Utility Commission and advocating at the state level would be a great option. The next question is this attendee says they often think of the grid as being a one-way path for electricity. How does it manage the electricity it receives from homes? So it manages the electricity through the installation of a bidirectional utility meter. This is the grid can run in both directions. However, they want to be able to track both the electricity going into your home and the electricity coming out of it. So while right now, your electricity meter only needs to track the electricity coming out of the grid into your home. The bidirectional meter will allow it to go out the other way and it will be able to track in both directions. This is also why the power has to be shut off when you do not have battery storage and you only have a solar system. If they have people working on the line or they're trying to prevent a fire or other danger, they need to make sure no power is flowing from your solar system back to your home, and they need to be able to shut that off and stop that from happening. So the next question says that when the grid goes down, they've heard some houses no longer can use their solar power. The system we're having installed later this month includes a battery. How will it work so that we can continue to have power generated by the solar panels during the day and then power from the battery when it's dark? So when this grid goes down, they need to be able to protect the linemen who are working on it. And that means they need to prevent any power from flowing back out to it, such as from the solar powers. By adding a battery, you're able to essentially island your home from the grid and make that a closed circuit so that the only power is going from your solar panels to the battery and out to your home and back again. And it is not going any where else. The system is called islanding, and that's how it works. I'm assuming you will still have a grid tied system, so it'll be up to you whether you want to use your battery when it's dark and not pull any power from the grid, or if you'd rather leave your battery fully charged in case of an emergency and the grid goes off suddenly, and only draw from the grid when absolutely necessary. This really comes down to personal preference, and it's up to you what works best for you. The next question I'm seeing is that they've heard there are restrictions in Portland when it comes to using Tesla battery storage. Is this true? Um, and if yes, what and why are those restrictions in place? I haven't heard anything about this. Last I talked to some solar contractors, they told me that most of the pushback against Tesla was coming from people not wanting to support the Tesla company and its founder. I am not familiar with any specific restrictions about Tesla battery storage, but I can certainly look into that more. The next question I'm seeing is, could I give an estimate of what can be done in a home with a 10 to 15 kilowatt hour battery in a 16,000 square foot home? So unfortunately, I cannot. It really depends on what you're using the battery for and what load you're using. So something like if you're running a dryer or a dishwasher, that requires more power than if you're just running a few lights. So it really will depend, and that's a great thing to talk to your solar contractor about, as they'll be able to give you a better idea of it. The next question I'm seeing is, has the sunsetting of the federal incentives affected the ETO incentive for solar and storage? So not directly. The Energy Trust of Oregon incentives are funded completely separately from the federal government. However, Energy Trust did up those incentives at the beginning of 2026 in order to try and help a little bit with the sunsetting of the federal incentives. Someone also asked if they can get a copy of this presentation, and the answer is yes. Over the next few days, I will be uploading a recording of this presentation to the Solar Oregon YouTube channel, and I will be emailing that out. So you'll be getting a copy of this in your email. Next question I'm seeing is, can I clarify if incentives apply for adding storage to an existing solar system? So, yes, the Energy Trust of Oregon incentives do apply if you're adding storage to an existing solar system. We just like to make sure people know that that does come if you're adding solar storage to an existing system. It comes with some extra costs, as you're having to have the contractors come out a second time and instead of doing everything all at once. Someone says they don't understand the 8 kilowatt installation example. Is this per hour, per day, or something else? So 8 kilowatt would be the total size of your solar system. So that is how the amount of watts of solar panels are meant to generate or could generate at full capacity, are expected to generate. I believe it is monthly. So. And someone else asked if I could explain kilowatt hours better. And the best idea of how to do that is to look at your electric bill and track it that way. Everyone's systems are going to be a little bit different. An older dishwasher is going to be much different than an Energy Star dishwasher. And so I'm not able to give an accurate idea of how kilowatt hours work, but that will be the unit used on your electric bill and be a great way to see how those work. I am going to continue answering questions. You guys are doing a great job asking them, and I'm going to go ahead and launch the last poll really quickly just so that I do not forget to do that before the end of the presentation. Someone asked if they could show the incentives again, and absolutely, give me a moment to go backwards. Here are the incentives. So you can see that is 2,500 for solar for PGE customers and $400 per kilowatt hour up to 5,000 for storage for PGE customers. Someone asked if they have it correct that if they have solar panels without batteries, then they can't use them when the power's out in your neighborhood. And yes, that is correct. Without a accompanying battery system, you are unable to use your solar panels to generate power when the grid is down. This is because they need to protect people from working on the line, and they cannot have any power flowing back out to the grid. Um, Someone else asked, what is the average solar kilowatt capacity of a home in Oregon? I do not know the average solar kilowatt capacity, but I do know that the average size of a solar system installed here in Oregon is 8 kilowatts. So that is what most people need in order to properly power their home for a to power their entire home. I'm still here to answer all your questions, but that's the last one I am seeing. But thank you so much for your participation. If you have any other questions, please put them in the chat. And if you would like to request a free custom analysis or bid, you can do so by scanning the QR code or clicking the link in the chat. And I'm going to stay on for at least another minute to see if any other questions come in. Oop, yes. Someone saying that they use around 700 kilowatt hours for a month. How does that relate to the 8 kilowatts? I do not have the information in front of mine for me to answer your question specifically right now. However, if you would like to send an email to info@solaroregon.org, I would be happy to answer your question in depth. And someone asked if people in Oregon can get Franklin batteries. They have some friends in California with them. I am not familiar with Franklin batteries, but as far as I know, systems that we use the same technologies across states, and if they are usable in California, they're usable here in Oregon. So someone asked again if I can explain kilowatt hours, give us an idea of how much certain items use. So how much power an item takes really depends on what the item is. So an Energy Star appliance uses a lot less than an older dishwasher, for example, or any older appliances. As an example, I'm just Googling quickly kilowatt hours of a dishwasher, and the average kilowatt hours of a dishwasher is 1.2 kilowatt hours. But it really depends on the needs of your system. Um, to see what you're using and what your appliances are, which is why discussing any appliance upgrades that you're planning on with your contractor is a great idea. Someone else asked how solar panel are most of the solar panels imported from out of the states, and how has tariffs impacted the solar industry? So tariffs are impacting the solar industry. We have seen some price rises occurring, and that's also been made worse by the sunsetting of the federal tax credit. Some solar panels are manufactured in the States, which is really great, but a lot of the components needed to produce the solar panels are just not things we can get in the States, things like mining silicone, and other minerals. And so those items are not. I believe, the National SEIA branch has a great information about how tariffs are impacting solar panels and how the Buy America for America, so I believe the program is called, is impacting solar and how to get solar panels that qualify for those credits. If you send an email to info@Solar Oregon, I'd be happy to find more information about that for you. So someone else asked if an item uses 1.2 kilowatt hours, is that how much it uses in 1 hour? So yes, that is how it works. So if you think a 1200-watt model, that would be 1.2 kilowatt hours. So kilo meaning thousand and then watt per hour. You guys are asking some great questions, and I'm here to get your questions answered. I'm going to end that poll. Thank you so much for filling it out. Please, I'm happy to stay on as more questions come in, but otherwise, I'm going to end the webinar in about 1 minute if I don't see any other questions come in. But thank you so much for your time, and feel free to send any other questions to info@solaroregon.org.